Hello, everyone. This final fourth presentation is regarding how our users should and could use our new modules within any platform that they uptake from us, as well as further engage with the activities of the PM3 initiative. To start, shown on this slide is a caricature of how our SIM-vascular PM3 codes should be used. So starting at the left-hand side top, the processing of imaging data is recommended to be done using the SIM-vascular's original graphical user interface. We do not intend providing any support for the GUI as such. Although we have accumulating experience of using the SIM-vascular GUI, the underlying tools are also available to us, such as, say, for example, MITK and ITK. But just to repeat, the SIM-vascular GUI is not supported. Furthermore, apart from imaging data, we are also going to receive a significant amounts of non-imaging data. For example, the velocity profiles of liquid through plastic or glass tubes. And this also needs to be prepared for multi-scale simulations. These modules have now been implemented within the PM3 codes, some within SIM-vascular and some without. And so these modules are available to the users open source. The simulations as such, any which it may be, 0D ordinary differential equations, 1D, 3D, or hybrid simulations that we perform either ourselves or in collaboration with our collaborators, should be performed using the non-GUI command line modules, for which we will come to, we will see where to get the modules from in a moment. Once the simulations are complete, the two tasks that remain are post-processing, for example, visualization of extracting hemodynamic risk factors from, say, velocity profiles and similar quantities that are obtained by post-processing. The suggestion is that the non-GUI modules should be used on the large data that are generated by the simulations. And these modules are available either as the kitware VTK parreview, or indeed the VTK library itself. If it works out to be efficient, perhaps we will do high-level scripting in MATLAB, or low-level scripting in shell programming. Finally, the outcomes of the simulations and post-processing will be documented either on the project's web portal or as documents that are circulated through the mailing list, or as a thesis written hopefully in LaTeX. Code annotation is also important, as the annotation, it has been, code annotation can easily be translated into documentation using already implemented methods in the work process. And so I thought perhaps we can now look at the currently available PM3 web portal and see what is being delivered to the users. And the URL of the web portal is written here. And so if we press on the URL, a browser comes up. These are several simple HTML pages that do not run any sophisticated scripts, in the expectation that the simplicity of the web pages will work on virtually all browsers available to our users. And so what we see on the first page here is a brief description of what we will do, in addition to a description of our team. Furthermore, The underlying technology required by both PM3 platforms as well as SimVascular are enlisted on one part in one part of the web portal. Furthermore, the SimVascular sources and binaries will be distributed in an open source manner through this web portal. If the SimVascular codes and SimVascular codes and newly implemented modules are not available on the Lawson Research web pages, please feel free to look into my GitHub repository. Also, please send in requests to join our PM3 mailing list on which we post regular announcements and updates. A certain amount of support has already been provided on how to acquire and implement SimVascular, and it has been described on one of the pages in the web portal to a certain extent, and this is potentially sufficient to have a successful implementation on Windows definitely, on Linux definitely, and most probably on a Mac computer as well. Word of warning is that on Macintosh computers, especially the older Macintosh computers, the locations at which the libraries and binaries are put by the installer may be different from what scripts that we provide for simulations. Furthermore, a part of the web portal describes the various projects that are ongoing, and this web page will be updated as the project continues. And finally, there is a documentation part of the web portal, which offers quite a few resources for installing, for getting started with the SimVascular GUI for image segmentation, the finite element meshing guide, as well as how to run simulations. Regardless of what SimVascular suggests, we will follow what we have decided, in that simulations will be performed without using the GUI. And so feel free to browse the web portal, which is updated regularly. And finally, there are several channels of communication, as well as sharing of data and codes. Firstly, social media is used on an increasing basis within our core workers here. So please do join us on the PM3 tutorials. Please also subscribe to the YouTube channel on which you are watching this video. In general, all codes will be synced up with my GitHub, and there's an error there. It shouldn't be MCCSSK22. It is just MCCSSK2. There's also an active mailing list, and subscription requests should be sent to me. And finally, to mention is, but not finally, but to mention, we currently have a bi-weekly lab meeting on Friday mornings between 10 and noon Eastern time. Feel free to join us in Zoom. It is likely to become a weekly event. And finally, we are open and we are keenly seeking new and exciting collaborations for both scientific software as well as use of our research. Thank you.